Hello! Today's video is going to be on rational exponents. And we're going to start off by just kind of looking at some things that we already know. So something that we're familiar with. We know that the square root of 4, well, that's 2. We know that the square root of negative 4 is 2i. That is an imaginary number. It is not real. So when you have a negative underneath that even root, that square root, we get an imaginary solution. The cube root of 8. So if I'm taking the cube root of 8, I'm asking myself, what number do I multiply by itself 3 times to get 8? And that's 2. 2 times 2 is 4. 4 times 2 is giving us 8. You could have also done that in your calculator. The cube root of negative 8. This is not an imaginary component. When I go back to the square root of negative 4, there's no number that I can multiply by itself to get a negative 4 because 2 times 2 gives you a positive 4 and a negative 2 times a negative 2 also gives you a positive 4. There's no way to get a negative 4. That's not the same when I have a cube root because I have an odd number. My answer here is a negative 2 because a negative 2 times a negative 2 times a negative 2 is where I get that negative 8 from. That's the difference between an even root and an odd root. When I have an odd number of negatives, I have a negative answer. So that's looking at roots that we know. This next part is looking at exponents and being really careful about how we evaluate our exponents. In this first one, I have a negative 3 squared. That is a negative 3 times 3. That negative is not in parentheses, so I am not squaring the negative, I am just squaring the 3. So I get a negative 9 as my answer. When I go to the next one, this is a negative 3 squared. So this one is a negative 3 times a negative 3, giving us that positive 9 answer. So again, looking at that positive-negative relationship, if I have an even number of negatives, my answer becomes positive. Well, this is just 3 times 3 times 3. 3 times is 27. My negative is in parentheses, so this is giving me that negative 3 times. I have an odd number of negatives, so my answer is going to be negative. That's the idea that you need to be familiar with and comfortable with to kind of understand what these rational exponents are. What you want to do is get comfortable with switching between radical form and exponential form, because radicals are just fractional exponents. So if we look at the generic form here, we've got the nth root of a to the m power. So we see m is the exponent of a. If I look at this exact same thing with a fractional exponent instead, m is the exponent, m is the numerator of that fractional exponent. The root of the radical is the denominator of the fractional exponent. So radicals only exist when we have a fractional exponent. Another way to write that is these two are the exact same, the nth root, we see the nth root. The m, the exponent there on a, can be inside the radical or it can be outside the radical. I usually always write it this way, but a lot of books and stuff will write it this way, so you just have to be familiar with both forms of that. When you are switching back and forth and you forget which number goes where, think about a simple example that we covered before. We know that the third root of 8 is 2. Therefore, we can rewrite the third root of 8 as 8 to the 1/3. That exponent inside of there is a 1. If you would have switched that numerator and denominator accidentally, instead of 1/3, if you had written it the other way as 8 and 3 over 1, you would have realized, well, 8 to the third power, that's a really large number. That's 512, which clearly isn't going to be true because if I'm taking the root of a number, it's going to be getting smaller. If you don't have a fractional exponent, then you don't have a radical. All of a sudden we learn about radicals and fractional exponents and you want to make everything into a radical. That's not true. If we have 8 to the third power, that's 512. That's not the cube root of 8. So only write your answer as a radical if it comes from a fractional exponent. So we're just going to work on going back between the two forms. So I see the cube root of 11, which has that to the first power. So it's going to be 11 to the 1/3 power. I've got my root, I've got my exponent, so this is x to the 3/4 power. The exponent is the numerator, the root is the denominator. We've got the 6th root, here's that funky one where it's outside, so this is y to the 2/6 power. However, you still have to follow your mathematical rules, so when you end up with a fraction that's 2/6, you do have to simplify it to 1/3. The last one is the square root of n to the 6th power. If you remember, you know that if I write x here, without me telling you, you know the coefficient is 1 and you know that the exponent is 1. Those are values that you know that don't have to be written. This is what happens with square roots. We never write it, but when we have a square root, we should know that that means it's a second root. So this becomes n to the 6/2, and 6/2 reduces down to 3. So that's n to the 3rd power. All right, we just got to switch it going the other direction now. So we're going to start with a fractional exponent and we're going to switch it to the radical. The numerator is going to stay with that number as the exponent. The denominator is going to be the root. If you feel more comfortable writing this, go ahead. If not, and you don't want to, we know that we generally just see this as the square root of 5. It's up to you. These two things mean exactly the same thing. X to the 3/5. The numerator is the exponent on the inside with that base of x. The denominator is the root, so this becomes the 5th root of x cubed. And that is it for our video on rational exponents.